Hello everyone, this is session 22 for the BSc third semester students of Organic Laboratory for the mathematics course. So here I'm going to cover Riemann integrals and definitions and properties of Riemann integral. So let us recall the upper and lower Riemann integral for the last session, that is session 21. So first definition was for lower Riemann integrable, and the second was for upper Riemann integrable. These were the conditions, the supremum of LPF, where P belongs to P of AB and it's denoted by a lower integral a bar to b f of x dx, that is for lower, and this is for upper. Now we have proved, there we have proved theorem 7 and 8. Next, now we have got the definition of Riemann integrals. So the definition 3, what it says, a bounded function f is said to be Riemann integrable or R integrable. When do we say it is Riemann integrable or a Riemann integrable? On AB if its lower and upper Riemann integrals are equal. When do we say if the lower Riemann integral and the upper Riemann integral are equal, then we say that the that bounded function f is Riemann integrable. Next we have got the definition 4. The common value of these integrals is called the Riemann integral of f on AB, and it is denoted by simply from integral from a to b f of x dx. That is a common value. Next, definition 5. The interval AB is called the range of integration. That means the difference. That is nothing but a range. Next, we have got definition 6. The numbers a and b are respectively called as the lower and upper limits of integration. Next, we have definition 7. The family of all bounded functions which are Riemann integrable on AB is denoted by R of AB. The family of all bounded functions which are Riemann integrable on the closed interval AB and is denoted by R of AB. Thus, if f is R Riemann integrable on AB, we write it as f belongs to R of AB. If it is Riemann integrable, then only we can write f belongs to R of AB. Now we have note first one, that is f is a, if suppose f is Riemann integrable, what is the first condition? If f is bounded on the closed interval AB, second point, the lower Riemann integral must be equal to the upper Riemann integral. Now we have got the properties of Riemann integral, that is theorem 9. If f belongs to R of AB, means if f is Riemann integrable, then this inequality will be satisfied. That small m into b minus a, that is infimum, which is less than or equal to a to b f of x dx. That is the condition, the Riemann integrable condition here. Where small m and capital R, infimum, supremum of f on the closed interval AB. Let us prove that. Since f belongs to R of AB, which means what? If f is Riemann integrable, then what we have, the lower Riemann integral must be equal to the upper Riemann integrable, which is equal to the common value, that is the integral from a to b f of x dx. Let's call that as 1 now. We know that small m into b minus is always less than or equal to the lower Riemann integral. This we have proved in your last session, that is theorem 8. Using this, let's see this theorem 8 now here, this part. Next, also since the integral a to b bar f of x dx is less than or equal to m into b minus a by theorem 8 again. So these two terms we have taken it from theorem 8. So combining this equation 2 and 3, what we'll get? M into b minus a is always less than or equal to the common value, that is integral from a to b f of x dx, which is less than or equal to capital M into b minus a. So now we have got multiple choice questions. A bounded function f is said to be Riemann integrable or R integrable on AB if its lower and upper Riemann integrals are, what is the condition? If they are equal, then only we can say it is Riemann integral. The answer is A here. Next we have the second question. If f is R integrable, means Riemann integrable, then what is the question? What is the answer? The two conditions must satisfy. First one is what? F is bounded on IB, and the second condition is the lower Riemann integral must be equal to the upper Riemann integral. So the answer is both A and B here. Next, third question. If f belongs to R of AB, then m into b minus a is less than or equal to, this is your theorem 9, right? So this statement is true. Fourth question. If f is a mapping from a to b to R is a bounded function, then the lower Riemann integral is less than or equal to the upper Riemann integral. The answer is true for this case. Next, if f is a mapping from a to b to r is a bounded function, then m into b minus a. This is the inequality. I think this is theorem 8. So we have just we have proved in the last session. So the answer is true in this case. So these are the references. Thank you for watching.